Now we will look at power in chapter 7. So power is the rate at which energy is delivered or work is done. And in your formula sheet, we have these formulas here, but P, power, is equal to the change in energy over time. And energy is in joules and time is in seconds. And if you look here, the unit of power has been named for Watt. I forget his first name, but we have unit of power is actually in watts, so joules per second or watts. Special name of watts, name for science. Okay, it's important to note as well that work, power, and energy are scalar quantities. We hadn't mentioned that before, but they don't need to have a direction associated with them. Let's just jump into some examples then. So we have in a hydro scheme, 1,000 kilograms of water per second falls through a height of 200 meters. What is the total power delivered to the turbine if the water flows with no loss of energy? Alright, so we've got power is equal to the change in energy over time. And this is we have our hydro dam here, and we have a bunch of water up here. Then it's simply a matter of changing potential energy, so it's equal to mgh over time. So we've got 1,000 kilos times by 9.81 times by 200 over 1 second, so it's just going to be per seconds, so you could leave it in there as a t if you wanted to. And when you work this out, it's 1.96 times 10 to the 6 watts, or joules per second, and that is equal to, remembering our prefixes, it's a, that's a funny dog, yeah, it's weird, what happened there, 1.96 megawatts. I think I wanted to write my M and W at the same time there, so it's a megawatt, 1.96 megawatt. If the water flow has an energy of 90%, so as we're falling down, we're losing a bunch of, gee, what's happening here? What am I pressing? Okay, I don't know. So anyway, water flow has an energy efficiency of 90%. Maybe a lot of that, maybe 10% of the energy is being lost to sound and heat and stuff. So we can just say that P is equal to 0.9, so 90% times by 1.96 megawatts. That's equal to 1.76 megawatts. Okay. So in the hydro scheme above, what must be the flow rate of the water in order to get an actual power output of 2 megawatts? Okay, so we can again start with, if we have P is equal to change in energy over time, and that's equal to the change in potential energy over time. Well, they've given us power is equal to 2 megawatts, so 2 times 10 to the 6 is equal to change in mass times by 9.81 times by 200 over time. So I'm going to divide both sides by this one here, so we end up with the change in flow, so change in kilograms per second is equal to 2 times 10 to the 6 divided by 9.81 times by 200, and that is equal to 1019 kilograms per second. Okay, so with an efficiency of 90%, okay, so we have to have more kilograms, so the flow for 90% will have to equal 1019 over 0.9, which is equal to 1130 kilograms per second. Alright, finally we have a person consumes 10 megajoules of energy in one day. What is the average power of the person? So the power is equal to change in energy over time. Okay, so we have 10 megajoules, which is 10 times 10 to the 6. Over, let's see, so we need time in seconds. So we've got 24 hours in a day, and we've got 60 minutes in an hour, and we have 60 seconds in a minute. And then that equals 116 joules per second, which is equal to 116 watts.